Have a review from last time. So the first rule that we had gone over last time was the product rule. And the product rule states that a to the power of m times a to the power of n is equivalent to a to the power of m plus n. If they're being multiplied and they have the same base, we add the exponents. Our second rule was the quotient rule. And the quotient rule states that a to the power of m over a to the power of n is equivalent to a to the power of m minus n. I think of this division symbol as a giant minus sign. But there is one important thing to remember. It is the numerator's exponent minus the denominator's exponent. That part is very important. So let's go ahead and begin with example 1. 2 over 2 times 2 times 2. Now we stated that deep in our gut we know we can reduce 2 over 2 to 1, leaving us with 2 times 2. Or I could even rewrite this as 2 to the power of 1 over 2 cubed. Now this would leave us to use our quotient rule. So our quotient rule states 2 to the power of numerator minus denominator. And that would give us 2 to the power of negative 2. But we already know that our answer here would give us, and we know that that gives us 2 is on the bottom, which is 2 squared, or simply our final answer of 1/4. So example 2, 3 squared over 3 cubed. Now, a lot of us went ahead and expanded our numerator and our denominator, and of course began to reduce to 1, like 3 over 3 and 3 over 3. Now, if we took that a little further here, I do have this up here giving us 1 times 1 is just 1, and all I'm left with is a third. Now, and actually, taking a look here, this is our quotient rule. I could have simply said 3 to the power of 2 minus 3 gives us our 3 to the power of negative 1. Interesting. Example number 3. 5 squared over 5 to the 5th power, of course, expanded out would look like this. Now, of course, I could reduce to 1 5 over 5 and 5 over 5, leaving 3 5s in the bottom. Or I could again use my quotient rule. And that says I have all the same base, so 5 to the power of 2 minus 5, that gives me 5 to the power of negative 3. Now, what you guys told me is I have 3 5s in the bottom, which is the same as 1 over 125. All right. Next example, example 4. 2 cubed over 2 to the 5th power. Of course, we can expand that out. Or I could simply have used my quotient rule, saying 2 to the 3rd minus 5 is equivalent to, well, I can definitely reduce a lot of these 2 over 2s into 1s, leaving me with just 2 squared. Now here I got 2 to the power of negative 2. Interesting. All right, example number 5. Now you guys had to know that this was coming up. 2 to the power of A over 2 to the power of B. Well, we don't even have to think about that one. We just did that on our previous notes, page 14, and it's right there. So I could say that I have base 2 raised to the power of a minus b. That's my quotient rule. Nothing special there. So let's up the ante. What if I gave you power of negative a? Now, this one gave you guys a little bit of trouble, and I think the word that I kept on hearing was inverse. And I really like that word for this case here because what we do is every time we had a negative number, to make it positive, I kept throwing it down into the denominator. So I'm going to say 1 over m to the power of positive a. Now let's try, how about 1 over m to the power of negative a. Now this time I already have my negative in the denominator. Before it was up here technically in the numerator. So yeah, what I would do is just flip it around and say that that would be, oh sorry, we actually don't need that, m to the power of positive a. Technically, I could write it over 1, just like I could have written this over 1, and all we did was flip it to get kind of like our reciprocal. But is that necessary? No. So you can simply erase that off if you don't want it there. Let's go ahead and continue with our last example. I guess this one is technically example 5. Why not? That's going to be 5 squared times 2 squared over 10. And there are several different ways that I saw you guys break this down. Now, some of y'all went ahead and broke it down by saying 5 times 5 and, well, 2 times 2. And then you broke down our 10 into, oh, sorry, that was actually supposed to be cubed. So you broke this down and said there's 3 tens, and 10 is simply 5 times 2. Now, I also saw something really interesting. I saw somebody take these here and change that into a 10, and then they simply left 10 times 10 times 10. Now, either of these would suffice, but nonetheless, we're going to go ahead and reduce to 1, right? Reduce to 1, reduce to 1, reduce to 1, and reduce to 1. Oh, goodness. So here, let's see, we should have, oh, I didn't write both of these 10s up here, duh. No wonder it wasn't looking right. I would have 10 over 10 and 10 over 10 reduced to 1. So I could have written 10 to the power of 2 minus 3, which gives me, or I also could have had 5 to the power of 2 minus 3 and times 2 to the power of 2 minus 3. That would leave us with 5 to the power of negative 1 times 2 to the power of negative 1. Nonetheless, we're getting our final answer as 1/10 because, well, all we have left here is a 10, or 10 to the power of negative 1. 5 and 2 would be thrown down to the bottom, so yeah, we get the same answer. So let's go ahead and write our final sentence. No negative exponents are allowed. Change your negative exponent to a positive by flipping it into the opposite numerator or denominator, aka the inverse or reciprocal. Don't forget to label this page 15.